2015 question number 2 starts off by giving us these two equations, f of x and g of x, as well as this general overall picture. Now you should know questions 1 and 2 are generally going to be your calculator based question, so you really have to understand how to use your calculator to graph these two. If I put this in my calculator and this in my calculator as well, I'll find that g of x is this very curvy one that goes up and down, and f of x is this long upward going curve here. But again, you would not know that unless you know how to use your calculator. Nevertheless, part A is asking us to find the sum of the area between regions R and S. Now, the easiest method to go about this is vertical slicing, so top of the curve minus bottom of the curve. But you see you run into an issue, right? At one point, remember this very curvy one here is going to be g of x, and this concave one, this one that's always concave up, is f of x. So at one point I'm going g of x minus f of x, g of x minus f of x, g of x minus f of x, until we get to this intersection. And then I'm going f of x minus g of x, f of x minus g of x. So we can't use a single integral. We're going to have to use two integrals to express this area. And that's where your point is going to go through. Now again, to find this intersection, you have to set these two equations equal to each other, or just graph them and plot for the intersections. Have your calculator solve the intersection, but you really have to know how to use your calculator in this instance. So here's my setup. Again, this intersection here, I'm just going to call it A. You're allowed to do that on the AP exam, but remember, you always have to include your answers to as much decimal places to be accurate. So this intersection happens at about x is equal to 1 point something, and you would have that for your own purposes, but when you're running out your general setup, you can just put a variable a. So from x is equal to 0 to x is equal to that a intersection, I'm going to be subtracting g of x minus f of x. And then I'm going to add plus where I left off a to 2. F of x minus g of x, so kind of the reverse. You compute this, let your calculator do the work, and you get your answer to be about 2.004. Now, overall point breakup, again, I cannot stress how important it is that even though this is a calculator question, you really have to show your setup. You get 2 points. Half of your points in this 4-point question comes from your setup, having the right integrals. Another point for having the correct bounds, right? From 0 to this a that you can define off to the side, a is equal to 1 point something. You only get an actual point for the answer. So I cannot stress how important it is to have the right setup, and as well as to make sure you define what A is off to the side of your paper as well. Part B is asking for volume by cross-sections. Cross-sections that are perpendicular to the x-axis, which are squares. Now, as I mentioned in other videos, I never memorize a set formula for these cross-sections. I just tell myself the volume is equal to the integral of any type of area of shape. So, and this is essentially understanding what the integral does. The integral, in some sense, in layman's terms, it gives you that extra dimension. So if area is base times height, this integral gives you the width, this extra dimension. So, and again, I don't memorize the formulas. I just know that I just need the area of that shape in here, and then integrate that. So in this case, my volume is going to be, because it's a square, the integral of base times height. Well, what's my base and what's my height? Well, they tell us, right, if they're squares, one side of the square is going from top of the curve to bottom of the curve. That's one side, right? And if it's a square, right, this is g of x, or excuse me, f of x minus g of x. This is one side. But if my height is equal to my base, then you can see why essentially I'm just going to do f of x minus g of x squared, because my base is equal to my height, and if I'm going to multiply base times height, it's the same thing as squaring if they're both the same. Again, starting from that point A of the intersection, make sure you define it off to the side of your paper what A is, all the way up to 2, f of x minus g of x. The only difference is that you are squaring this time, whereas before, when you're finding area, you did not square. Because again, here, this is just area and an extra integral to get your other dimension. Here, I'm just going to take the single dimension. This one dimension, this is my length, This other integral gives me like my height or whatever. So part A was about area, part B is about volume, and specifically of a square, the shape. This will vary, but you have to understand what the integral does. Now again, most of your points come from the setup. You only gain 1 point for the actual answer. So even if you're not calculator savvy, just having the right setup will give you most of the points. Last question. This is pretty much very similar to related rates. They want the vertical distance or change at which the vertical distance changes between f of x and g of x, right? This region S here. Because remember, this concave up curve is f of x, this curvy curve, this up and down one, is g of x. So we have to start, what is h equal to, right? If we want the rate of change of h, which is this distance, well, h is going to be top of the curve minus bottom of the curve. And then I'm going to have to derive that to get it a rate, right? dh, dt, or whatever, if it was a really rate question. So off to the side here, that's how I'd set it up. They want the rate at which h changes, but you need to define what h is. So I'm going to say here, h is equal to f of x minus g of x. It's that simple. Now they want the rate of at which h changes. And anytime you hear rate, you know that in calculus, a rate is the same thing as the derivative. That's the key concept here. So the derivative of h is simply the derivative of whatever we have here. So instead of f of x minus g of x, it's f prime minus g prime. That's it. Already so far, this single portion right here, that's going to get you a point, 1 point. The AP exam is huge on overall setup. If you can set it up, you're going to get most of the points. It doesn't matter if you get the wrong answer. The final point comes for your answer. They want us to evaluate the instant x is equal to 1.8. So you're simply going to put h prime of 1.8 is equal to f prime of 1.8 minus g prime of 1.8. And it gives you the rate of change at the instant, right? X is equal to 1.8. So somewhere around here-ish. It gives you not the overall distance between them, but how much it changes at that point. And you have to understand the difference between the apparent function and the rate at which it changes. But nonetheless, 1 point for the answer, not a big deal. Make sure you practice on your setup for these questions.